Today we're deep diving into a topic that sparks debate across forums, social media, and listening rooms. Do audio cables really sound different? Some people swear by the differences they claim to hear, while others dismiss them entirely as a figment of our imagination, believing that cables can have no meaningful impact on the sound. There's two main things to consider in this debate. 1. Can we measure the electrical differences between two cables designed for the same function but constructed with different materials or methods? And 2. If we can measure the differences, can we demonstrate that the differences are actually audible? So those are the main points to consider. Bear with me through some of this, as it's going to be controversial and might not appear to align with popular thinking on the topic. I'm going to focus here primarily on speaker cables, but pretty much everything I discuss here can apply equally to interconnects or any cable that carries the audio signal. If you find any of this useful, please remember to hit like and subscribe. So, to do this sensibly, one has to assume some basic prerequisites. 1. Any cable considered in this discussion must at least be fit for purpose and be constructed following good design principles, using established materials such as copper, silver, gold for the conductor, and nylon, Teflon, silk, etc. for the insulator. 2. The cable runs must be of practical lengths and limits that would be encountered in a typical home environment. While some home audio applications might require unusually long cable runs, we need to constrain the data to sensible limits. So getting to the first question, can we measure the electrical differences between two cables designed for the same function? I think we can put this to bed fairly quickly and without too much fuss. We can measure clear differences in the electrical properties of cables. There should really be no dispute here. Cables have properties such as resistance, capacitance, and inductance, and the way in which the signal passes through the conductor is also impacted by phenomena like skin effect, which changes depending on the type of conductor and its gauge. If you go to a manufacturer's website, you'll generally find published properties for resistance and capacitance per meter of cable, so you can quickly and easily see the different specs for different cables. So the next question is, can we hear these differences? This is where things become more difficult as we're moving from an objective assessment to a mostly subjective one. So how do we approach this? How do we determine whether the small changes in the electrical properties of different audio cables are audible, or if they're of such a small magnitude that they're undetectable by human hearing? Double-blind listening tests are the gold standard for objectively determining whether there are audible differences between components, including cables. In such tests, neither the listener nor the person administering the test knows which cable is being used at any given time, eliminating biases that might influence perception. Numerous double-blind listening tests have been conducted over the years to assess whether listeners can reliably distinguish between different audio cables. Tests involving both speaker and interconnect cables, and in most cases, listeners fail to consistently identify or detect sonic changes in the cables used, suggesting on the surface that any perceived differences in cable specs under normal conditions are not audible. For instance, a study by the Audio Engineering Society found that, under blind testing conditions, participants were unable to distinguish between different cables when assessed under controlled listening tests in a highly resolving audio system. These findings can be further supported by the vast amount of data from various print publications, audio groups, and online forums. Some of it anecdotal, but most of it tending to support the conclusion that changing audio cables isn't something our ear-brain interface can detect, given the constraints and requirements of a double-blind listening test. So this suggests a conclusion whereby audio cables may have measurable electrical differences, but the differences are not significant enough to affect the sound in a way that humans can detect. Before I get to my own thoughts, let's just dig into the conclusion a little further and try to answer a burning question. Given that double-blind testing indicates no detectable differences between different types of cable, why do people still believe that they can hear differences? Even after blind tests fail to reveal consistent and repeatable differences in sound, some audiophiles continue to claim they can hear them. Let's look at some possible explanations. Auditory memory is short. The human ear and brain struggle to accurately recall sound over short periods. Any change in perception could be due to the natural limitations of auditory memory rather than a true difference in the signal. After spending a significant amount of money on high-end cables, listeners might subconsciously convince themselves that they hear a difference, to avoid feeling like they've wasted money. This is known as cognitive dissonance, where the mind rationalizes an expensive purchase by believing it must have a beneficial effect. Some audiophiles believe they have exceptional hearing abilities and can perceive differences that others cannot. However, double-blind tests have shown that even individuals with highly trained ears, such as professional musicians and audio engineers, struggle to differentiate between cables in a controlled setting. So what we think we're hearing may be a product of expectation bias, memory limitations, the placebo effect, and confirmation bias. Okay, so we've settled the argument once and for all, right? Controlled testing proves that we don't have golden ears and our expensive cables are a waste of money. I don't think we're ready to give up just yet. The question of whether cables affect sound quality is binary and thus demands a straightforward yes or no answer. It isn't about whether every single cable will sound different regardless of which cable it's compared to, but rather, it's about whether or not any two cables can sound different. If they can, then the question is answered and the issue resolved, even if the differences aren't found universally. Obviously, we need to select cables of the same length and for the same intended function, but we can't cherry-pick from a pile of wire to prove whatever point we're trying to emphasize. Yes, if I looked at the manufacturer's data on a wide range of cables and picked two with almost identical values, then I would absolutely not expect to be able to hear any difference between those two cables. But if I picked two cables with polar opposite specs or construction types, would I expect to be able to hear a difference in the sound between these two cables? That is the question being asked. If two different cables can sound different and we can demonstrate such, then the debate is essentially over. It's a binary question, and it requires a binary answer. And cost is irrelevant to the discussion. The cost versus performance aspect is for an entirely different debate. It has no bearing on the question being asked. So let's move this forward with a simple and provable experiment that anyone with a decent audio rig can perform. Taking speaker cables, for example, what would we look for in a cable to determine its suitability for use in a listening test, to help us conclude whether different speaker cables can sound different? Is there any one aspect of its design or construction that would bear more heavily on how it sounded? Again, with the prerequisite that it is fit for its intended purpose, has sufficient gauge to carry the minimal current involved, and so on, then the property that most affects a speaker cable's performance is its impedance, which is driven primarily by its physical construction. Quite simply, the impedance of a speaker cable increases when the two primary conductors are placed farther apart. Greater spacing reduces capacitance, increases inductance, and leads to a higher cable impedance. Bringing the conductors closer together increases capacitance and lowers inductance, resulting in lower impedance and more current flow for a given voltage. High inductance can cause treble roll-off, making highs sound dull. High capacitance can blur high frequencies, reducing clarity and precision, especially in longer cable runs. Higher resistance limits power transfer, resulting in weaker, less controlled bass. So cable design impacts sound in specific ways, and certain amplifier types like tube and Class D are more susceptible to some of these effects. Of course, all of these issues are more noticeable in high-resolution systems. If your system isn't highly resolving, you may not be able to readily detect the differences, but don't assume that's the case for all of us and all systems. The above claims are very easily verifiable or refutable. You don't even need two pairs of speaker cables to compare. If you own speaker cables that have individual cores for plus and minus, just try moving the two conductors apart by a few inches, listening, then move them closer together so that the insulated cores are touching. You can even twist the two conductors together, design permitting. Assuming a requisite level of resolution in your system, you should hear a very notable difference, particularly in the overall tonal balance of the sound. So, within our binary outcome framework, where we ask the simple question, can audio cables affect the sound of our systems, It's very easy to demonstrate a positive conclusion. You can do it simply by yourself at home. You don't even need the complexities of double-blind testing. Not all electrical parameters in an audio cable can be adjusted to deliver the dramatic and obvious differences seen in the experiment I've just described. And often changing cables will result in differences which are minimal, marginal, barely audible, or non-existent. In these cases, I don't rule out the possibility that claiming to hear differences in sound might be the result of the biases we talked about earlier. But with our binary outcome framework, it doesn't matter whether the differences are small or whether listeners can reliably detect them. The mere existence of these differences is sufficient to conclude that the pursuit of experimenting with different cables by audiophiles is logically justified. People in denial may try to shift the debate to whether or not the differences are worth pursuing from a cost-benefit perspective. This is a different argument, and it's entirely subjective. No person can tell another person what something is worth to that person. So, the next time someone tells you that changing speaker cables doesn't make a difference, think back to the simple test that I've just outlined. And if you have a pair of cables on hand with individual cores not combined in the same outer sheath, you can easily demonstrate how simple it is to manipulate the sound of your system by changing cable conductor proximities. At the end of the day, trust your ears. If you hear a difference, there is one. Your audio system is the sum of all its parts, and cables are an important part of the chain. So experiment with different cables, listen critically, and discover what works best in your system. While I was trying to avoid talking about cable cost because it isn't relevant to the question posed at the start, you don't need to spend a fortune on expensive cables. The trick is to find cables with a set of electrical values that happen to work synergistically with the other components in your system, such as your power amp and speakers. The values you're looking for don't automatically live inside expensive cables. They can exist just as easily in cheaper cables too. So try a few different brands at different price points, and stick with whatever sounds the best to you. In my next video, I'll be taking a closer look at the cost versus performance debate and debunking some common audiophile myths, particularly around how much value is placed on expensive audio cables as a proportion of the overall system cost. So, if that interests you, make sure to like this video, subscribe to the channel, and hit the notification bell so YouTube will let you know when the new video drops. Thanks for watching, and as always, leave a comment below with your thoughts on audio cables. Do you hear a difference? Let's discuss.
Don't buy no more shit. Don't buy no more speakers. Don't buy no more amps. Let me live. I put a stop on that card. I tell you I will. Don't buy no more shit. Baby, no more. Baby, no more. Speakers, don't buy no more amps. Let me live. I put a stop on that card. I tell you I will. Don't buy no more shit.